We are still going to be talking about motion of connected particles in this video. Now, mind you, this one is particularly a continuation of the previous one, where we had two masses. Okay, we had two masses. Okay, hanging over a pulley. Now, the one here I'm going to call M1, just like the previous video. So, if you haven't watched that one, I would advise you watch that one, so that it make it easier for you to understand this one. Okay, now this is M2, and in this case this pulley is having a mass M. Okay, capital is an M, that's what I'm going to call it. And because of that reason, the tensions acting on these two strings are going to be different. Okay, so the tension here I'm going to call it T2, tension here I'm going to call it T1. This one is going to act upward, opposing the motion of this, and we're assuming M2 is greater than M1. Okay, and then this one is going to act upward as well. Okay, if it is pulling, it's acting upward, and this one is going to act down. So I'm going to call this W1 and I'll call this W2. Okay, now due to the fact that the pulley, its mass is not being ignored, okay, we're going to have an angular acceleration. Okay, let's see, it's moving this way. It's going to have an angular acceleration as well as a torque. Now here to here we're going to call it the radius of the disc. Okay, now due to the parameters that I have just outlined on the board, this means we're going to make use of a few rotational equation motion. So that, okay, now let's start by beginning at the equations so that we can find the acceleration for a system like this. Okay, for that reason, remember, since it's having a radius and a mass, it's causing the two tensions to be different. Hence, we're going to first of all have a torque which is simply equal to the moments of inertia times the angular acceleration. Now you can compare this to F equals ma. This is the rotational form of Hooke's law. Okay, angular acceleration, linear acceleration, mass, moment of inertia, force, and then we have torque. Okay, now first things first, let's find the net torque acting on this disc. Okay, to get our first equation, let's find the net torque. Now to do that, we can see that T2 is greater than T1 because M2 is greater than M1. Okay, hence the difference in the moments being produced by this guy is going to equal the torque. Okay, so we're going to have T2 times the radius of the disc. Okay, we're going to have T2 times R subtracting T1 times the radius as well. Remember, it has to be perpendicular. Okay, they are perpendicular, so I have T1 times the radius as well. That will equal the torque, that is the net torque. Moment of inertia times angular acceleration. Now mind you, there is a relationship between angular acceleration and linear acceleration. This is something that we're going to talk about in a different video. Okay, now linear acceleration is angular acceleration times radius. Okay, so angular acceleration is linear acceleration over radius, and this acceleration is also one, the linear acceleration, not the angular acceleration. Okay, and then of course we do know that moments of inertia for a circular disc that is rotating about the center, okay, is equal to 1/2 mr squared. That's quite basic. Okay, 1/2 mr squared. So we're going to plug in these two guys into this equation to get our first equation. So we're going to have T2 times R minus T1 times R equals moments of inertia is 1/2 mr squared, okay, multiplied by the angular acceleration is linear acceleration over radius. So we have linear acceleration over radius. Okay, now we can see that the arrow cancels out on both sides, so these arrows, okay, they can take out one arrow here and this one takes out this one, so I left with T2 minus T1 equals 1/2 m. What's left there? I think that should be ma. Okay, mind you, this is the mass of the disc, that is this pulley we are having here. So I'm going to call this equation 1. Let's now solve for or bring out equation that connects T2 to its mass and T1 to its mass as well. Okay, so we're going to consider T1 first. T1 is pulling the weight upward, so it's going in this direction. Hence, T1 is greater than W1. So I'm going to be having T1 minus W1 equals M1A. Now, what's W1? W1 is simply the mass times the acceleration, times gravity rather, acceleration to gravity. So we have T1 minus M1G equals M1A. Okay, so from here T1 will equal M1A plus M1B. I'm going to call this equation 1. Equation 2 rather, okay? I'm going to call this equation 2 instead. Okay? and then we're going to come to this next mass, which is W2, and we'll notice that W2 minus T2 equals M2A. Okay, now substituting, we get M2G minus T2 equals M2A. Now what we want to do next is we're going to make T2 the subject, or making T2 the subject. I'll write it here. Making T2 subject, we're going to get T2 equals M2G, okay, minus M2A. Now we've obtained T1 and T2. I'll call this equation 3. Let's now substitute into the first equation. So I'm going to substitute equation 2 and 3 into equation 1. Okay, by doing that, T2 is going to be M2G minus M2A. Okay, that's T2 minus T1. Now we're having a negative sign here, so we're going to have minus A and minus A. So we're having minus M1A minus M2G. Okay, and after doing that, it's going to be equal to 1 over 2 MA, 1 over 2 BM times A. Now, what we want to do is make A the subject, because we are looking for the linear acceleration. So that's what I'm going to do. Let's take everything, including A, to the other side. We're going to have M2G minus M2G. Is that what we should be having? This should be M1G rather, okay? This should be M1G, not M2G. Okay, so that's M1G. We have M2G minus M1G, and taking this one to the other side, I have 1 over 2 MA plus M2A plus M1A. Okay, so from here we can factorize. We have M2G minus M1G equals A is common, so we have A into bracket big M over 2 plus M1 plus M2. I'm just writing M1 and M2 as I believe it to make it easier for students to recognize. Okay, so from here, dividing both sides by the acceleration, we have acceleration equals G is also common, so we can factorize. So we have G into bracket M2 minus M1, okay, divided by M over 2 plus M1 plus M2. Now here's the formula for calculating the acceleration. Okay, here's the formula for calculating the acceleration. This will be equation 4. Formula for calculating the acceleration when a pulley has a mass, okay, and we describe the mass as capital letter M. Hence, it has an angular acceleration on the next. And if you have to find the angular acceleration, all you have to do is, after finding the linear acceleration, you come here and make use of the relationship, okay? Angular acceleration is linear acceleration over radius, of which you'll be giving the radius to the equation, okay? Now, what if you ask to find the tension? That's T1 and T2. I'm still going to show you. All you have to do is put A into this equation, so I'm going to get T1. Okay, I'm just going to do that for T1 and T2. So T1, first of all, T1 from equation 2 is M1A plus M1G. Okay, so I'm going to write it in this case. Just watch. I'm going to have M1 times A, so we'll multiply A by M1. Okay, and then we're going to add the weights to it. So instead of writing M1A, or it depends on anyone you want. Okay, so we're going to have M1G into bracket M2 minus M1, okay, divided by M over 2 plus M1 plus M2, okay, plus the weights of what? Of M1, okay. So this is the tension for the first one. Now, how about the tension for the second one? All we have to do, we'll go to equation 3, where we'll have it's equation 3. We're going to be subtracting this time around, okay. So for the next tension, what we're going to have should be T2, okay, equals what's M2? M2 times G is the weight. So we have weight of the second mass subtracting the mass, okay, which in this case is M2. We're going to have M2 times the acceleration is G into brackets M2 minus M1 divided by big M over 2 plus M1 plus M2. Okay, here's the formula for calculating the next tension. So I think this procedure are quite easy and simplified to the fullest. Okay, so in the next few videos we'll be solving the question concerning this, and we'll see how we make use of these formulas, or even if you forget the formulas, because there's so much we've done that you might find confusing trying to come. So what we want to do is learn how to derive these things and to make everything very, very easy. Now, if you do enjoy this video, of course, I said this one is a continuation of the previous one. So if you did not get it, I would advise to watch that one first before coming to this one. Now, if you did understand this one, probably after watching that one or not, I advise you still subscribe to the YouTube channel and share, okay, to your friends and family, for those persons that are required to know these things for their exams or tests and the likes. Okay, now also do not forget to click on the notification bell so that when I upload a new video on stuff like this, okay, whether being maths, physics or chemistry or any science courses, okay, it's to reach you first before it gets to others so that you can learn as well. Okay, so do it to subscribe to the channel. The name is Dr. Flash, and click on the notification bell for more videos. See you in the next video. Thank you.